Good afternoon everyone. Today I am going to discuss about the grid and cloud computing unit 3. So coming to the topic, so in previous videos we have discussed about the virtualization of CPU, memory and input output devices. In this we are having different types. We have explained about these content, hardware support for virtualization, CPU virtualization, hardware assisted CPU virtualization, and this is the image of these hardware assisted virtualization, and virtualization of memory and input output devices. So these things all we have discussed in the previous class. So okay, now I am going to continue the class with the virtualization, cluster and resource management. So okay, so if in a physical cluster is a collection of physical server that are interconnected with each other. So in this we having, so this is the diagram. So if you see the diagram we can understand this is the physical cluster and this is the virtual cluster. In the physical cluster we are having the group of servers are connected with each other, and so in the physical cluster we are having the group of servers. These servers are connected with each other through the network server, okay, network to the network connection, okay. So in this we are having the virtual cluster. So these virtual cluster have VM machines. So we can say it is also VM machines and that are interconnected with logically by a virtual network. So these lines are called the virtual networks. So if we talk about the physical cluster, it comes under the physical servers and they are connected with the LAN. And if we talk about the virtual cluster, so they are having the virtual machines and these are interconnected logically with the virtual network, okay. So across several physical networks, okay, physical networks. So we will study here in this we are having some critical issues of the virtual clusters. See, this is the, so if you see this in this issue we have the live migration of virtual machines, memory and file migrations and dynamic development of virtual clusters. So and when a general virtual machine is initialized, the administrator has manually write the configuration information. This increases his workload, particularly when more and more virtual machines join the clusters, okay na? So whenever the virtual machines are increases, so this is the diagram. So in this diagram this is the virtual machines. When the virtual machines is increases more and more, what he said that when the virtual machines increases more and more, so workload will be increases, okay. So as a solution to this, a service is needed to take care of the configuration information like capacity, speed, etc. of the virtual machines. The best example is Amazon's Elastic Compute Cloud EC2, which provides the elastic computing power in a cloud, okay. So this is the example. So in this cluster, in this virtual cluster, the live migrations of virtual machines, memory and file migrations and dynamic development of virtual clusters, and these virtual machines in virtual cluster have following interesting properties. So okay na, so virtual cluster, what are the properties here? So virtual cluster nodes can be either a physical or virtual machines with a different operating system, and the purpose of using virtual machines consolidated multiple functionalities of the same server, and virtual machines run with the guest operating system. So these virtual machines, so whatever the virtual machines we are having in the virtual cluster, so these runs with the guest operating system, okay, guest operating system runs with a guest operating system that manage the resources in the physical machine. So the purpose of using virtual machines having these functionalities of the same server. So the size of the virtual cluster can be grow and shrink dynamically, and the purpose and virtual machines can be replicated. Virtual machines can be replicated in multiple servers and multiple servers for the purpose of distributing the parallelism, fault tolerance and disastrous recovery, okay. And the failure of some physical nodes will slow the work, but the failure of virtual machine causes no harm. So whenever the physical cluster, whenever the physical nodes will be fails, whenever the physical nodes will be fails or slow down, the complete virtualization's failure will be occurred. If any virtual machine, so failure of some any physical nodes will slow down the work. So, whenever these physical machines, so this physical clusters in this we having the physical machines, whenever the it will be slowed down, it will be fail, it will be failure. So, the work will be slowed down, and but the virtual machines will be failed, there is no harm. So, it will be fault tolerance is high, fault tolerance is very high. Okay. In the virtual clusters, based on the applications partitioning and customization, most important thing is to determine how to store those images in the system efficiently. So, there are common installations for most users or applications such as operating system or user level programming libraries. The software packages can be pre-installed as templates. With these templates, user can build their own software stacks. New operating system instance can be copied from the template virtual machine. Okay. So, this is the diagram. So, okay, next fast deployment and effective scheduling. So, what is mean by fast deployment and effective scheduling? Deployment means two things: to construct and distribute the software stacks, that is operating system, libraries, applications. So, to a physical node inside the cluster, physical node inside the cluster as fast as possible, and quickly switch runtime environment from one user's virtual cluster to another user's virtual cluster. If one user virtual cluster users finishes using his system, and the corresponding virtual cluster should shut down or suspend quickly to save the resource to run another virtual machines for other users. So, okay, this is called the fast deployment and effective scheduling. So, next one is the high performance virtual storage. So, there are 4 steps to deploy. There are 4 steps to deploy group of virtual machines onto a target, onto the target cluster. One is preparing for the virtual machine, preparing the disk image, configuring the virtual machines, choosing the destination nodes and executing the virtual machine deployment command on every host. Many systems use templates to simplify the disk image preparation process. A template is a disk image that includes a pre-installed operating system with or without certain application software. So, templates could implement the COW, it means copy or write format. A new COW backup file is very small and easy to create and transfer. So, this is called the high performance virtual storage. In this high performance virtual storage, we having some target in cluster, preparing the disk image, configuring the virtual machines, choosing the destination nodes, executing the virtual machine deployment commands at every host. So, these are the steps. So, what is mean by live virtual machine migration steps? So, there are 4 ways to manage a virtual cluster. First, we can use guest based manager by using by which the cluster manager resides on the guest system. In case of multiple virtualizations form a virtual cluster, we can build a cluster manager on the host system. The host based manager surprises the guest system and restore the guest system on another physical machine. The third way is manage a virtual cluster is to use an independent cluster manager on both the host and guest systems. Finally, you can use an integrated cluster on the guest and host system. This means the manager must be designed to distinguish between virtualized resources and physical resources. In this, we are having some 4 steps. Okay, 4 ways. So, that is an active state is defined by virtualization, okay, platform under which virtualization is not enabled, and an active state refers to a virtualization machine that has been instanted at the virtualization platform to perform a real task. Okay. So, a passed state corresponds to a virtual machine that has been instantiated but disabled to process a task or passed in a waiting state. In the virtual machine enters a suspended state if its a machine file, the virtual resources are stored back to the disk. Okay, in this we having the 4 ways. We said we can use a guest based manager by which the cluster manager resides inside the guest operating system. For example, a Linux cluster can run different guest operating system on top of the Zen hypervisor. So when we bring a host based manager, which itself is a cluster manager on the host system, for example VMware, high availability, okay, so high availability system that can be restored the guest system after failure. Independent cluster manager which can be used both on the host and the guest, making infrastructure complex. Finally, integrated cluster manager on the guest and host operating system. Here we manage clearly distinguish between the physical and virtual resources. So this is the diagram of the live migration process of a virtual machine from one host to another. So in this live migration of virtual machines from one machine to another consisting of 6 steps. So first stage 0, step 0 to 1, step 0 to 1, okay, start migration. Here we are starting the migration, okay, now here we are starting the migration. This step makes preparation of the migration including determining migration, virtual machines and the destination host at the step 0 and 1. At step 1, at step 2, okay, at step 1 initializing and container the target host. At step 2 transfer memory. Here we are transferring the memory. In step 2 we are transferring the memory, since the whole execution state of virtual machine is stored in memory, sending the virtual machine memory to the destination node. Continuity of the service provided by the virtual machines. All of the memory data is transferred. At step 3, suspended the virtual machines and copy the last portion of the data. Migration virtual machine executing is suspended when the last round's memory data is transferred. Okay, now in step 4 and 5, commit and activate the new host. After all the needed data is copied on the destination host, the virtual machine reloads the states and recovers the execution of a program in it, and service provided by the virtualization continues. So this is the working of the diagram. So this is the steps we have explained now. So next coming to memory migration. So what is mean by memory migration? So when one of the system migrates to another physical node, we should consider the following issues. Memory migration can be in the range of hundreds of megabytes to a few gigabytes in a typical system today, and it needs to done in efficient manner. The internet suspended resume technique exploits temporal locality as memory states are like to have gigabyte are like to have considerable overlap in the suspended and resumed instance of virtual machines. So to exploit the temporal locality, each file in the file system is represented as a tree of small subfiles, and copy of these trees exist in both the suspend and resumed virtual machine instance. What is mean by file system migration? So to support the in the location independent view of the file system that is available on all the hosts, a simple way to achieve this to provide each virtual machine with its own virtual disk, which the file system is mapped, and transport the content of these virtual disk along with the other state of virtual machines. A distributed file system is used in ISR, serving as a transport mechanism for propagation of suspended virtual state. The actual file system themselves are not mapped on the distributed file system. So this is called the file system migration. Next coming to network migration. A migration should maintain open network connections. It should not depend on the forwarding mechanism, that is mediators or mobile mechanisms. So each virtual machine should be assigned a unique IP or MAC, that is media access control addresses, which is different from the host machine. The mapping of IP and MAC addresses to their respective virtual machines is done by the VMM. The VMM maintains a mapping of virtual machine IP and MAC addresses to the corresponding virtualization. Live migration is a key feature of the system virtualization technologies. We focus on virtual machine migration within the cluster environmental, where a network accessible storage system such as storage area network or network attached storage is employed. Only memory and CPU status needs to transferred from the source node to the target node. So, this is called the network migration. So, next coming to pre-copy. In this live migration, we having two approaches, pre-copy and post-copy, which is mainly used in live migration. All the memory pages are first transferred, if then copies the modified pages at last round interactively. The performance degradation will occur because migration will be encountering the dirty pages all round in the network before getting to the right destination, that causing any another problem. Iteration should also increases. To encounter these problems, checking the point recovery process, it is used in different positions to take care of the above problems and increase the performance. That is called the pre-copy. Post-copy is nothing but memory pages are transferred only once during the migration process. Threshold time allocated migration is reduced, but downtime is higher than that pre-copy. So, this is the two approaches in live migration. Okay. So, next coming to virtualization for data center automation. So, what is mean by virtualization for data center automation? Data center automation refers huge volumes of hardware, software, database resources. In this data centers can be allocated dynamically to millions of internet users simultaneously with a guaranteed quality of service. The latest virtualization development highlights the high availability, backup services, workloads, balancing, and further increases in client bases. Server consolidation in data centers. So, in heterogeneous workloads in the data centers can be roughly divided into two categories, chatty workloads and non-interactive workloads. Chatty workloads may be burst at some point and turn to a silent state at some other point. For example, video services can be used by a lot of people at night and few people uses it during a day. Non-interactive workloads do not require people's efforts to make progress after they are submitted. Server consideration is an approach to improve the low utility ratio of hardware resources by reducing the number of physical servers. The use of virtual machine increases resources management complexity. So, the hardware utilization in many underutilized servers are consolidated into fewer servers to enhance the resource utilization. Consolidation also facilitates backup services and disasters recovery. So, in the virtual environmental, the image of the guest operating system and their applications are readily cloned and reused. Total cost of ownership is reduced. Improves the availability and business continuity. Okay. So, this is the points we have to follow the data center automation. Okay. So, automation and data center operation includes resource scheduling, architecture support, power management, automatic or autonomic resource management, performance of analytical models, and so on. In virtualized data centers, we have efficient on-demand fine-grained scheduler is on a key factors to improve the resource utilization. So, dynamic CPU allocation is based on virtual machine utilizations and application level of quality of service matrices. On this method, both CPU and memory following as well as automatically adjusting the resources based on varying the workloads in hosted services. Another scheme we uses a two-level resources management system to handle the complexity involved. A local controller at virtual machine levels and the global controller at server level are designed. So, this is called the data center and automation. Okay. So, virtual. Okay. So, in this is improve the server utility ratio of hardware device and reducing the number of physical servers. We are existing the two servers considered central and physical constellation, virtualization based server constellation. The second method is widely used in these days and it has some advantages. Constellation increases the hardware utilization, with more provisioning of available resources. The total cost of owning and using the data centers is reduced in low maintenance, low cooling, low cabling, etc. cabling. It enables availability and business continuity. The crashes of the guest operating system has no effect upon the host operating system. So, data centers are most consider several factors like resource scheduling, power management, performance of analytical models and so on to improve the utilization of data centers. Okay. And dynamic CPU, and we have explained now only these schemes about dynamic CPU allocation and virtualization utilization. Okay. So, next coming to virtual storage management. So, virtual storage includes the storage managed by virtual machine made and guest operating system. So, the data stored in the environmental can be classified into two categories: virtual machine images and application data. The virtual machine images are special to the virtual environmental, while application data includes all the other data which is same as the data is traditional operating system environmental. In data centers, there are thousands of virtual machines which causes the virtual machine image to become flooded. Parallax is a distributed storage system customized for virtualization environment. Content addressable storage is a solution to reduce the total size of virtualization virtual machine images, and therefore we support a large set of virtual machine based system in data centers. Okay. So, this is called the virtual storage management. Okay. Next one, this is the virtual machines. So, virtual storage management. Okay. So, physical host, this is the storage application virtual machines. So, we are storing the data here. So, this is the storage administration domain. Here we having some functionalities such as snapshot facilities that are traditionally implemented within a storage devices are pushed into the per host pre-host storage appliance virtual machines which interact with the simple shared block device and may be also use local physical disks. So, this is the shared block device. Any network block device may be used in this storage appliance. Okay. And these are the different virtual machines we are having. So, group of virtual machines available in the hypervisor. So, this is the storage here. Okay. In this we are having resources. Okay. So, this is the diagram of the parallax. Okay. So, next coming to cloud operating system for virtualization data centers. Okay. In this virtual infrastructure managers and operating system are specially tailored for virtualization data centers which own a large number of servers in cluster. Nimbus, Eucalyptus and Nebula are all open source softwares available to the public. So, only vSphere 4 is a proprietary operating system for cloud resources virtualization and management over data centers. So, these virtualization infrastructure managers are used to create virtual machines and aggregate them into virtual clusters as elastic resources. So, okay. So, in this Eucalyptus for virtual networking of private cloud. In this Eucalyptus is the open source software system. So, intended mainly for supporting the infrastructure as a service clouds. The system primarily supports the virtualization, networking and management of virtual machines. Okay. There are three resources managers in is specialized below. Instance manager, and what is meant by instance? It controls the execution, inspections and terminating of virtual machines instance and the host machines where it runs. Group of managers is second one. It gathers information about virtual machine execution and schedules them on a specific IAMS. IAMS means instance manager. It also manages the virtual instance network. Third one is cloud manager, CM. It is a entry point into the cloud for both users and administrator. It gathers the information about the resources, allocates them by proper scheduling and implements them through the group managers. So, these are the 3 types. So, next is trust manager and virtualization of data centers. So, what is the trust? We are allocating, we recollect the virtual machines VMware. Which hypervisor is a layer between the host and operating system and hardware to create one or more virtual machines on a single platform. So, a virtual machine encapsulates the guest operating system and its current state and can transport it through the network as a SSI. At the function in a network where transportation, any traducers may get into the image on the concerned hypervisor itself and post danger on both the image and the host system. Examples are subtle problem lies in reusing a random number of cryptography. So, okay, so next VM based virtualization machine, virtual machine based intrusion detection. Instructions or unauthorized access to a computer from another network user, and instruction detection systems which is built on the host operating system can be divided into 2 types: host based IDS and network based IDS. Okay. So, any problem with the virtual machine will not pose problems for other virtual machines. VMware hypervisor audits the hardware allocation and usage for the virtual machines regularly. So, we notice any abnormal changes. So, the host and guest operating system are fully isolated from each other. So, next coming to, this is the diagram, this is the IDS and this is the monitored host. Here we have the policy engine, policy module, policy framework. This is the applications, guest operating system, virtual machines. This is the operating system interface library and this is the virtual machine monitor. So, it will be monitor the system, okay, and monitored host applications, these are applications and this is the guest operating. This is a guest operating system completely managing this one. Okay. So, this is the architecture of live wire of instruction detection using the dedicated virtual machines. Okay. So, next coming to the, in this above diagram, we are granting the IDS run only on the highly privileged virtual machines. Notice that policies play an important role here. A policy framework can be monitor the events in different guest operating system of different virtual machines by using an operating system interface library to determine which grant is secure and which is not. System also may access logs and to analyze which is an instruction and which is secure. The IDS log services is based on the operating system kernel and Unix kernel is hard to break. Even if host machine is taken over the hackers, the IDS logbook remains unaffected. The security problems on the cloud mainly arises the transport of images through the network from one location to another. The hypervisor must be used more effectively and efficiently to deny any changes for the hackers. So, this is called the virtual machine trust manager. So, thank you.